Given that f of x is root of x plus 2 and k of x is 1 over x minus 5, determine k of f of x. So that's going to be k of root x plus 2. So we need to substitute that there. And so it will be 1 over root x plus 2, take away 5. We now want the domain and range of k of f, which is the function that we just found. And the domain is just going to be all reals greater than or equal to 0. We know that we need to think about the square root. We can't put any negatives in there. But if you look at the denominator, that denominator can never be 0. So we don't need to exclude any other value of x. Now to think about the range, just consider that that is actually negative 5 plus 1 over root x plus 2. Now, the largest that this part can be is a half. So negative 5 plus a half, or negative 4.5, is the largest the function can possibly be. When x is very, very large, this part tends to 0, so the function will tend to negative 5. So we can say that y is a real. Y is greater than negative 5, and that's strictly greater because it never actually will be negative 5, it just tends to it. But it's less than or equal to negative 4.5. Given that the inverse function is x minus 2 squared, is it true that f, the inverse of 0, is equal to 4? Well, let's think about the original f, which remember was root x plus 2. So that looks like this, and the domain for that would be greater than or equal to 2. Now that domain has to become, that range has to become the domain for the inverse function. So 0 is not part of the domain for the inverse function. Now, we're given that k of g of x is x squared plus 2 over 3. We want an expression for g of x. Now, remember that the k is 1 over x take away 5. So k of g of x is 1 over g of x take away 5. And that's going to be equal to x squared plus 2 over 3. So 1 over g of x is going to be x squared plus 2 over 3 plus 15 over 3, which is just the 5 moved over. So 1 over g of x is going to be x squared plus 17 on 3, meaning that g of x is going to be 3 over x squared plus 17.